Good morning, children. Today our topic is motion and measurement of distances. So what is motion? If you say that an object, it changed its position from one point to another point, you can say that the object is in motion, right? So object is changing its position, it's moving. The movement is called as motion. And measurement of distances. An object, it moved from one point to another point. Here the point A, here is an object. Here the point B, this object, it moved from here to here. So you call this as motion. Object moved from position A to position B. You call it as a motion. But here the question is, how much distance it traveled? So what is the distance between point A and B? Somebody told you the ball has gone from A to B. So you notice that there is some motion. Yes, there is some motion because it moved from place A to B. So motion is there, it's fixed. How much distance it moved? That is the measurement of distances. Actually, how to do this? In this lesson, we are going to understand the types of motion and how to measure the distances between two different points. So let us begin with the very well known thing, the transport that we see every day, we use every day. You are using transport to come to your school. You see that your friends and yourself, you are going to school by different means of transport. You may be taking the school bus, your friend may be taking his own car, his or her father may be dropping in their own car or on their own bike. Some people may be coming in the auto rickshaw. Some people may be coming by walk. If their house is very close by to the school, they may be coming by walk. Some by their own bicycles, they ride and come to the school. So you see, that's a bicycle. It's a means of transport. Bike is a means of transport. Car is a means of transport. School bus is a means of transport. So they are using different means of transport to come to the school, the same point. Right. You might be going out for your vacation, outing, out of station to the pilgrim spots or tourist spots with your parents in summer holidays. You may be going to your grandmother or grandfather's house. How do you go? You take a means of transport. You go by either bus or by car or by motorbike if it is very close. Or if it is very far, you take a flight or train. You book a train ticket, or you may book a flight if they are staying abroad. They are in US or Australia, Canada. You are going by flight. So you are taking a particular means of transport depending upon the distance. See here the point. If it is a very close by distance, you take some bicycle or motorcycle. If it is very far distance, you take a train or a flight. So it all depends upon the distance. So we have different means of transport. As I told you that we have cycle, we have bus, we have car, bike, train, flight, all this. Right. So which one do we choose? We choose the means of transport on basing different factors. One is the distance. The first one is the distance. Second one is your budget, affordability. How much you can afford. You can buy a flight ticket and go in flight. You can take a train ticket and go in train. But there is a lot of variation in the price, even though the difference is distance is very high. So anyway, we are not going to talk about this. Let us see the distance. Depending upon the distance, we will choose the means of transport. Your mother asked you to go to the grocery shop, go to the mart and buy some grocery items or vegetables. If the market is very close, you go by walk. If the market is very far, you take the bicycle. If it is too far, you may ask your father or somebody to drop you at that point on their motorbike. So distance is the factor that decides what kind of transport that we choose. Right? So before we see that, let us see the transport and the history of transport, how the transportation is developed and what are the various means of transportation modern transport have come into use. In the olden days, there was no technology. In ancient times, people used to use wooden logs for their travel. Wooden logs to travel in water. There were no boats and ships, just wooden logs. The cut wooden logs were used as a means of transport by the people to travel or to cross the rivers or to cross the channels, canals and all. Right. So later they started using the wooden logs to construct boats, and later they developed into big ships. So that was the thing, how the ships were evolved. People started inventing, combining their ideas and creating a new thing that was happened in such a way. So later, the transport on the road, it was very difficult. Till when? Till the invention of wheel was done. Wheel. So that was a great invention, wheel, because it changed the phase of the transportation. So because of the wheels, they could make carts. So these carts are powered by animals. So the carts were pulled by animals. Horse, tongas, horse pull the cart. Bullock carts, bullock pull the cart. So here the thing, for the cart to move smoothly, it need to have a wheel. So invention of the wheel led to so many developments and inventions in science. So fire and wheel are considered two major inventions in science. Right? So wheels were discovered. They were invented. Right? So now wheel, it allowed to make so many vehicles. They are powered by animals. So later, what was happened? Later, there was a new machine came into use which replaced the animals. The machines, they could run on their own with the help of a engine. So the steam engine, James Watt steam engine. So the steam engine, it allowed the vehicles to go on their own without the help of animal power or human power. Right? So the steam engines. So after this steam engine, after the invention of this steam engine, so what happened? It changed the total thing. Motors have come. So these motors, they are running the vehicles. Motor vehicles have come. So after that, aeroplanes have come. Right? And after that, these motors are fixed to the boats. Mechanized boats have come. Ships have come, which are running automatically with the help of steam. Motor vehicles have come, trains have come, right? Locomotives, the trains. Now we have electrical trains, monorail, supersonic flights, and we have space shuttles to travel into the space also. Spacecrafts also have come. And now, at this particular point in 2017 and 18, we have so many different modes of transportation is going to come into use, where you need not use your brain to navigate yourself to which place you are going. Your computer, if you feed it in your computer or in your mobile, it can take you to the place where you want it to go. It can navigate, right? It can drive you to your destination. So such a sophisticated transport system is going to come. So this is all the advancement in the transportation, but it has begun with the wheels, and then motor vehicles, steam engines, later the discovery of electricity, the combination of mechanics and electricity. So finally it has come to so many new modern vehicles and modes of transportation. So which means of transport that we select, it depends upon the distance, how much you need to travel. So you are at the point, that is, I say that you are in Kerala. So you wanted to go to Delhi. So you are asked to go to Delhi. Do you take out your bicycle to go to Delhi or your bike to go to Delhi? You will book a train ticket which can take you to Delhi. So you can go for a train. If not, if you wanted to go a bit faster, then you will book a flight. Okay. So depending upon the distance, how much distance that you have to travel, you will decide what modes of transport that you can choose or pick up. But how do you know the distance? Somebody is telling you, just you will Google it. You will take your smartphone or computer, go to Google, www.google.com, then you will type what is the distance between Kerala and Delhi. Then you will come to know how many kilometers it is. That's it. Thereby, very closely you will find so many ads related to that, where you can click and book your ticket and go. So you need not measure the distance between two cities or two places in a known countries or a continent, because it was all done by the people. It's all updated in internet. You can see that what is the distance. But here you can notice one thing, that it will show the distance from Kerala to Delhi. So what is the distance between Kerala to Delhi? It is 2671 kilometer. So I googled it. If you Google it, you will come to know that this distance. So what is given? Here two things are given here. One is number and the other one is km, that is unit. So when you are talking about a distance, then you will find two things. One is the number, the other one is the unit. Right. So 2671 kilometers is the distance. You need not measure it. But here, if there is a situation, if you are asked to measure, how do you do that? How do you measure it? So what do you need? Let us see the situation. So here is your desk in your classroom. So in the desk, here you are sitting here. You are sitting, and beside you there is one more person sitting you beside. Beside you there is one more boy sitting here. The teacher asked you to sit in your place exactly. Do not get into the other's place. So the desk is shared among two people. So this is shared among A and B. The teacher told, do not come into the place of A to B. So they need to sit in their own place. That means they have to share the bench. That means they have to define their territories, means their border, which they should not cross. This person should not cross into his area. This person should not go into his area. So how can they do that? Teacher asked them to draw a line at the center. Here just I am estimating the distance. I am putting a line here, but it is not exactly the center. It's rough estimation, just I am estimating. So if any one of this A or B, if they have drawn a line with estimation, they will go for a conflict. They say that it is not accurate. You are taking more area. I am taking less area. I am given less area. Likewise, they will fight together. So it should be a standard division. It should be a very accurate division of the space. Then only both of them will accept it. Otherwise, they don't accept. If this person is telling this is the center, he will not accept. If this boy is telling this is the center, he will not accept, because it should have some scientific proof that both are equal. It is at the center. So now the teacher asked to solve their problem. They wanted to measure the distance and solve it. So what do they have to measure with? Measurement means comparison of a quantity with a known quantity. Right? Comparison. Just they are comparing the length of the desk with the things that they have. So what they have, these people, they have gilli danda with them. You know the gilli danda that is used to play. So gilli danda, they used the gilli danda like this, gilli and danda, to measure. So when they started measuring, totally it has come like 4 gillis and 2 dandas. Right? So 1 danda and 2 gilli will do for the length. But sometimes, so this gilli danda they use it to measure, okay, 1 gilli, 1 danda, 1 gilli, that is 1 half. 1 gilli, 1 danda and 1 gilli, that is another half. In that way it is equal. But here the question comes like Mr. B says that gilli danda was bought by A, so I don't accept that. I have my own gilli danda with which I will measure. That is a different case. Because all gilli danda need not be in same size. So again there is a confusion. So they wanted to measure with the cricket bat. It is not possible here. They have measured 1 bat, 2 bat. They cannot exactly divide that with the help of cricket bat. So cricket bat is not a suitable device to measure. Gilli danda is not a suitable device to measure because always it is not justified. If they are measuring with such things, some of the area of the desk might be left, or sometimes the measuring device will be much more longer than the bench. So that is the case. So here, without any measuring tool, they can solve this with an idea. Let's see. They have taken one string, one thread and measured till the end of the bench. They have cut it here. So this length they have taken here to here. Now they folded this like this back. They folded the thread. So at this center point they marked it. It is 1 by 2. And again they folded it here. They marked 1 by 4. So with this they can accurately measure the distance. But even with strings it is not possible always. If it is a very long distance, you cannot take such a long string to measure. So there is a need, there is a necessity to have some special devices for measurements. There is a need to measure the distances. There is a need to represent the distance in special units. Then only we can understand. And it should be accepted by everybody. Otherwise there is a conflict. If I say one thing, yes, this is the standard. Somebody says something that is the standard. There will be a conflict. I don't accept his words. He don't accept my words. So again it is a confusion. So for the measurement of distances, there we need a standard unit of measurement. Now let's see the standard units of measurement. So what are standard units and what are non-standard units? Standard unit in the sense it should be accepted by everybody. It should be the same in each and every case. Wherever, whoever measures that, it should be same. But non-standard. In ancient days, people used to follow the non-standard units to measure the things. Say for example, here we have foot. To measure the distance of a room, they used to use their foot length. So 20 by 30 feet. 20 by 30 feet they used to walk and see that 20 by 30 feet is the size. So that they used to take it as a unit for the measurement of distance. But is it standard? No. Why it is not standard? Because the length of the foot may vary from person to person. Some people they may be having short foot which is around 8 inches or 9 inches. Some people may be having 10 to 11 inches of foot. So the size of the foot is different. It's unique for each person. It is different, varied. So which is not same in all cases. It is not standard. So it is a non-standard unit of measurement. Then the cubit. Cubit is the length between the elbow to the tip of the finger. This is the cubit. So the cubit length also was used in ancient world to measure the things, to measure different items. Even you see nowadays, if you go to a temple and then you can find the flower garlands are measured by this cubit. You can see the cubits, right? But this is also not standard unit of measurement. How can you say that it's not standard? Because it doesn't meet the parameter, that is everybody's cubit is not same. Mine may be larger. If the person is so short, his hands are very small, it's a very small cubit. There is a lot of variation, right? If I buy flowers from a person who is having a big cubit, I'll be benefited. If I buy flowers from the person who is very short, I'll be lost, right? So that is the cubit. So it is also a non-standard unit of measurement. Next one is also hand span. Using the hand span, if you stretch your hand the distance between the tip of your thumb and the distance between your thumb and your pinky, that is your little hand, little finger. So this distance is the hand span. So the hand span is also used to measure the distances. So that was also not a standard unit. And width of the finger, angle. In ancient India, they used to use their fingers, angul. And this is that mutti, fist. So this is the size comparison, okay. And they used to follow the foot and cubit. And they used to measure the cloth, 1 yard of cloth, by holding the cloth, holding in this way, the ending of the hand till their chin. If they open the cloth like this, and that volume of the cloth is considered as 1 yard. So that was the measurement. But all these are non-accurate units of measurement because they vary from person to person. So it's not standard, right? So what we are talking is that standard unit of measurement. Then what is the standard unit of measurement? When was it found? Where was it found? Where was it determined? That was in French, by French people. In France, it was done in 1780. The standard unit of measurement, it was given as 1 meter. 1 meter. So what is 1 meter? It is a length decided, that particular length as 1 meter. Everybody should take that particular length as 1 meter. So that 1 meter is divided into 100 centimeters. So they have taken one long scale and they have given this particular length a name, that is meter, and it is given some divisions, 100 divisions. 100 centimeters equal to 1 meter. Now each centimeter is having 10 millimeters. That means 1 meter is equal to 1000 millimeters. So this meter, it was accepted by the whole unit, all the world. So that is considered as standard unit of measurement, International System of Units, SI unit system. International units, that means international in the sense all the nations accepted that. International System of Units, SI system. There you find 1 meter equal to 100 centimeters, 1 centimeter equal to 10 millimeters. So 1 meter is equal to 1000 millimeters. That is the standard unit. So everywhere you can buy a meter scale. If you go to a tailor, he uses a meter scale. If you go to a carpenter, he uses a tape which is measured with meters, 1 meter, 2 meter. So all this is done in the similar way, standard. Wherever you go, if you take a meter scale, it will show only 100 centimeters, not 50 centimeters, 70 centimeters. They cannot put the choice of their own, okay, they cannot put the number of their own choice. They should keep that 100 centimeter for 1 meter. They should divide the 1 meter scale into 100 centimeter. And they cannot take the centimeter of their own choice. The centimeter must be having 10 millimeters. And overall 1000 millimeters should make 1 meter. That is the standard unit of length. Right. This is for to measure the smaller length. If to measure the long length, like distance between two places, as earlier I told, the distance between Kerala and Delhi, it is 2600 kilometers. There I used the word kilometers. So the bigger unit of meter is kilometers. 1000 meters is equal to 1 kilometer. That is the bigger unit. So this is the standard unit of measurement. Using a hand span, using a cubit, using foot, using other body parts to measure the things is not accurate because they are varied from person to person. So it will be different from person to person. It's not standard. So the standard unit of measurement is meter. So now let us see. We have seen the standard unit of measurement is meter. So we follow the same. Even you take the same unit of measurement to do your classwork in your mathematics or in physics. If you have to draw any diagrams given by your teacher, you use a scale, a ruler that is found in your geometry box. So you may be using a small scale, small ruler which is having the graduation up to 15 centimeters. These are centimeters. Now let's see how to use your scale properly. There are certain rules by which you can use your scale properly to get exact result, to measure the distances properly. If you do not use the scale properly, you may go for a wrong value. You may not be able to measure the distance accurately. Say for example, here you have a box. This is the box. How do you measure the length of this box? Here is the box. So you have placed the scale. See that the first point, hold the scale properly. See that the scale is aligned straight. Don't keep the scale like this or like this. See the edges of the box and the scale. They are aligned properly. Then you can take the measurement. You can count 1, 2, 3, 4, 5, 6, 7. And you have crossed 7 centimeters. After crossing 7 centimeters, there are tiny markings which show the millimeter. So after crossing 7, you have gone to 3. That means 7.3 centimeter. That means till 7 centimeter, you have crossed 7 and you crossed 3 subsections, smaller marks. You can see here the bigger markings show the distance between centimeter. Here to here 1 centimeter, here to here 1 centimeter. In between you have 10 smaller lines, small divisions, right? So the distance we have crossed here, 7 we crossed, but we didn't reach 8. So you cannot say that the length of the box is 8 centimeter because just we crossed 7, we didn't reach 8. So after crossing 7, how many divisions we crossed? 3. So you count it as 7.3 centimeters. And what care you have to take, you should keep the scale or ruler straight. Don't keep it upside down, tilted like this, so by that you will get a wrong value. That is the first point. Second thing is count properly. See that you have kept the scale at the edge, that is the 0 point. Now 0 to 1, 1 centimeter, 1 to 2, 2 centimeter, 2 to 3, 3 centimeter, 4 centimeter, 5 centimeter. So the counting must be proper. Sometimes if your scale is broken like this at the edges, you don't have the scale completely because the 0 marking and some divisions are gone. Because it is the old scale or ruler, the endings are worn out. Now you can start measuring from 1, right? So you can count from 1 and you can see that till how many divisions it is coming. Then what to do in the final value? Say for example, here you are using the scale. This is one more box we have here. So this is your scale. But in your scale, what happened is that the edges were broken. You don't have the edges. So here you have 1, 2, 3, 4, 5, 6, 7, 9. So you kept the scale like this to the box. It started at 1, ended at 9. So you cannot say that this is 9 centimeter. How comes it 9 centimeters? Let us count. This is here to here 1 centimeter, here to here 2 centimeter, here to here 3 centimeter, here to here 4, here to here 5, here to here 6, here to here 7, here to here 8. It only 8 centimeter, not 9. Just you cannot take this number because you left 1 centimeter here. You didn't start at 0. If you start at 1, the final reading 9 minus 1 because 1 you have left here. So deduct that 1, you will get 8 centimeter. So if you are using your scale at 1 degree, that is at 1 centimeter, then you have to deduct 1 from the final value. If you are using the scale right from the beginning, that is from the 0 centimeter, then you can take the final value as your distance. This is the way how you have to measure. And you need to take one more care while using a scale. You should see the value where the measurement ends matches with the scale exactly at the straight point at 90 degrees. That means if this is your eye, you should see like this. You cannot see from side. You cannot measure like this. That will be wrong. You cannot measure like this. Like this. It should be straight to you. So your view should be straight to the number which you are counting, the position of the scale. Then you will get the exact value. So these 3 points are to be kept in mind while measuring the distance of any object using a meter scale or a small scale or a tape or whatsoever it is. So we have seen how to measure the distance between two different points by using a meter scale. Right, a ruler can be used to measure the distance, or a tape can be used to measure the distance between 2 points. Here we have 2 more points, A and B. Now how to measure the distance between A and B? It's very simple. You may get a doubt. Don't you know that? We can use a scale. We can bring a scale and see that what is the distance in centimeters. But here the thing is, point A to B, there is a path. This is a park. This is a path, walking area by which we can reach A to B. So the distance we have to measure is the path of this particular point A to B. But this path is not straight. To use a scale. How is the path? It is a curved line or a curved path. It is not straight. How can I measure this now? So a scale, I cannot use the scale. Scale is because it's straight. It is not accurate. If you measure the distance between A and B using a scale, it is not correct. So here I can take help of a thread or a rope to measure the distance of a curved line. So let us see how to do that. Here I have a jute thread. See, to measure the distance, first I have to hold the thread at the starting point. Now I keep the thread to some other point, to some other extent here. I can hold it like, and with the other hand I am taking one more point. I am extending it. I am holding another point. I am holding that point with my left hand, and I am taking out the thread with my right hand, and I am leaving the left hand, holding this point again. I am taking out the thread. I am holding, leaving this, and again I am doing the same till the end of that point. So this is the length of the curved line. You see that it is much bigger, right? If you keep it straight. So if you keep the thread in this position, this thread will fit into this line. So this is the length of the curved line. You can take this length and you can keep it near a scale to measure how many centimeters it is. It is very simple. So this is the way how a curved line is measured. So moving things around us, we find so many things moving around us, right? Simply just I am sitting in a chair and seeing that I switched on the fan. I see the fan is moving. It is moving. There is a kind of motion. I see some fly. It came into my room. It's going here and there buzzing. I'm feared that it may go into my ears. Just I plugged my ears. So it's taking different path. It's not going in a particular way. It's going all around, and finally it went off through the window. Right. So see that. Then I found some ants were taking some sugar, fell on the ground. The ants, they were coming in one particular pattern. They are taking a path and going up. So different things around us, whether living or non-living, they show some kind of motion. Sometimes we can observe a one particular pattern in the motion. Right. Just I switched on the fan is rotating. So it is moving in one particular fashion. I see the pendulum of a clock. It's going in one particular fashion. You might have observed the different kind of motions when you go to a fair. If you go to a fun fair, what do you find over there? You find so many rides, right? You enjoy the rides. So how are the rides? What kind of rides do you find over there? You will find a big giant wheel. Yes. You take the giant wheel, you sit in the giant wheel, you go up there and you come down in a circular way. So there you are kept in a motion. You will enjoy the thrill. You will get the thrill when you are engaged in such a motion. What is that motion? It's a circular motion. And if you are kept in a, that is Mary Columbus. Mary Columbus It's like a swing. You will be going up and coming back. You have a to and fro motion, but that motion has a specific pattern. It goes up and comes down. You take a roller coaster, it goes this way, that way, this way, that way, finally comes down. It's a zigzag motion. You take a ride of a mini train, it goes in a circular track, it moves in such a way. So that motion has also got some pattern. Right. So this way you will find different kinds of motion. We observe different kinds of motion around us. So shall we categorize the different types of motion here? Let's see. The first one is rectilinear motion. So what is this rectilinear motion? That is the motion in which some object goes in a straight line. You see the highways, national highways. It's a very lengthy, long roads in a straight path. You can see the cars that are traveling. So they'll be going in a straight line. The motion of a car in a straight road, you call it as a rectilinear motion. The soldiers, they are marching. You see that Republic Day parade. Have you ever seen the Republic Day parade? So in the parade, all the items and the people, they'll be going in a straight line. That is called as rectilinear motion. So if any object that moves in a straight line, you call it as a rectilinear motion. So sometimes we find the motion, it takes place in a circular path. You call that motion as circular motion. It's called as circular motion. So where it takes the round path, it's rotating the blades of a fan. The blades of a fan. And what else? You can find merry-go-round. So that also goes in circular way. You see that the oil mills and water mills, they are pulled by the bullocks. The bulls, they will be rotating around the well to draw the water from the well and to grind the oil, seeds to get the oil. The bulls they use it to rotate around the motor. So by that the seeds were ground to get the oil. So that is all circular motion. Sometimes we see some objects will be going to and fro, going front and coming back. This to and fro motion is called as oscillatory motion. So you might have seen the rhymes hickory dickory clock, hickory dickory dock. So there you find that the clock's pendulum is moving to and fro, to and fro, to and fro. This is called as oscillatory motion. If anything is going to and fro, you call it as oscillatory motion. So we see different types of motion. One is the rectilinear motion, something which is traveling in a straight line. Circular motion, which is going something round and round and round in a fixed path. And oscillatory motion, something which is going to and fro, to and fro. If any motion is happening, if any motion is repeated with a specific time interval, right? So with a specific timing, you call it as a periodic motion. Periodic motion. Right? So the motion, it happens with a specific fixed set of time, with a specific time interval. It's a periodic motion. Right? So the pendulum, it will take 1 second to go to and fro. That is a periodic motion. Okay, so you enjoy the music. In the music, you will find the drums beating in a periodic way. They are not played haphazardly. They are played with a rhythm. Rhythm means it maintains a specific time. So then you will enjoy it. Right? So that is a periodic motion. Even you see that the moon goes around the earth in 28 days. It takes, for every 28 days, I will do that same. It's a periodic motion. Of course, it is a circular motion, but it is periodic. Here, the pendulum, of course, it is an oscillatory motion, but it is periodic. Right? So this way we can categorize the motions into rectilinear motion, circular motion, oscillatory motion. Again we can further classify them into periodic motion and non-periodic motions.